Hi everyone, notes 5.2 are on equations of medians, altitudes, and right bisectors. And these are three different types of lines. And we're going to go through and do one example of each type of line right here. And we're going to define what each one of these words means, okay? So let's go ahead and define what a median is. So a median is a segment that joins the vertex of a triangle to the midpoint of its opposite side. Okay, so this right here, this is the median. So this line that we're looking at right here is called a median, and it connects the vertex. So this right here is called the vertex to the midpoint of the opposite side. Okay, and since every triangle has three vertices, every triangle has three medians. So I could also have another median. You don't have to draw this in, but I'm just showing you all three medians. We could also have another median right here that connects this vertex to the midpoint of this side. And we can also have another median right here where this is the midpoint of this side right here, and it connects it to the vertex right here. So there are always going to be three medians in every single triangle, okay? So here's a list step by step of what to do in order to figure this out. But we've also explored this, so hopefully you have a little bit of an understanding of how to do this. So right here it says determine the equation of the median from J for the triangle with the following vertices. So the first thing I need to do is graph out the triangle so I can see what's going on. So J is at 2, 5. K is at 4, negative 1. And L is at negative 2, negative 5. Notice how I haven't put the letters in yet because I like to do all the vertices of the triangle first, and then I can label the letters in a way that I can make sure that they're not in the middle of the triangle. And then I just connect all of these points together. So here's what my triangle looks like. And it says to find the median from J. So that means that I want to draw in from J right here, from this vertex right here, which means that I need to connect it to the midpoint of this line LK. So the first thing I need to do is find the midpoint of LK. So to find the midpoint, we know the formula is x1 plus x2 over 2, and then y1 plus y2 over 2. It's the midpoint of LK. Right? So I'm going to use these 2 points to figure out this midpoint right here. So to find that, I'm going to add x1, which is this 4 right here, and x2, which is this negative 2 here. So I would do 4 plus negative 2 all over 2. And then I would do the same thing for y1 and y2. So y1 is negative 1, y2 is negative 5. So this ends up becoming 2 over 2 and negative 6 over 2. So my midpoint right here is 1, negative 3. And if I graph that out, I can see, oh, for sure, my midpoint is 1, negative 3. So we'll call this the midpoint of LK, okay? And then I'm going to connect that vertex to the midpoint, and this is my median. So this is the equation of the line that I'm trying to find. Okay, so to find the equation of this line, the next thing I need to do is find the slope of this line. So what is the slope of this line going to be? So to figure out the slope, I'm going to use the slope formula. But to find the slope, I need to know what my 2 points are. So I'm going to be using from J to M, the midpoint of LK. And that's what this is saying right here, the slope from J to the midpoint of LK. So we know that J is going to be, let me just mark this off right here. We know that J is going to be 2, 5. And then we also figured out that the midpoint is 1, negative 3. So when I plug this in right here, I would get negative 3 minus 5 over 1 minus 2, which turns into negative 8 over negative 1, which is 8. So we know that the slope of this line right here is a positive 8, which should make sense to you because if I were to do the rise over the run, this went up by 8, this went over by 1. So if I'm trying to find the equation of the line, I need two things. I need M and I need B, right? So now we figured out the M. So the next thing I need to do, let's check these off, is to use the slope in either point to find the y-intercept. So we're going to use the equation y equals mx plus b And we know that the m is 8. So I will fill in an 8 right here. And then I also need to plug in either one of these points, either the j or the midpoint, to find out what b is. It doesn't matter, you'll get the same answer. So here I will substitute in the point j, which is 2, 5. Okay, so what I will do here is I would plug in 5 equals 8 times 2 plus b, and then I get 16 plus b, and then to solve for b I would get negative 11. So now I know what b is. So that means that my whole entire equation would be y equals 8x minus 11. And that's how we find the equation for the median from vertex J. Okay? Don't forget to write down any questions you have as we go through this. All right, the next type of special line that we have here is something called a perpendicular or a right bisector. So if you look right here, this is our perpendicular bisector, and I'll just use the symbol for perpendicular right here. So when you hear the word bisector, it means it's cutting something in half. So this right here is a line that is perpendicular to this opposite side right here, and it goes through the point that cuts the opposite side in half. So it goes through the midpoint right here. So right here, a perpendicular bisector is a segment that passes through the midpoint of a line segment at 90 degrees. Because remember, perpendicular means it makes a 90-degree angle. So this right here is a perpendicular bisector. Since every triangle has 3 sides, every triangle has 3 perpendicular bisectors. So same thing, you don't have to graph this out or draw this out. But here, this point right here is the midpoint of this side. This is its perpendicular bisector. It makes a right angle. And then over here, this is the midpoint of this side right here. And then this is the perpendicular bisector right here as well. Okay, so one thing that I want you to make sure that you fully understand here, though, is that a perpendicular bisector does not have to go through the vertex. So if you notice right here, this line is not going through this vertex. Sometimes it will, but it doesn't have to go through that vertex. Okay, so let's go ahead and take a look at number 2. So in number 2, it says right here, below is one of the most famous right triangles, the Bermuda Triangle. A ship captain plans to take the path of the perpendicular bisector from the segment EF. So this right here is the perpendicular bisector of segment EF right here. So that means that because it's bisecting EF, this segment and this segment are equal to each other. Okay? He wishes to be tracked the whole way because he doesn't want to disappear in that Bermuda Triangle. So can you determine the equation of his ship? So the first thing that we need to do is I want to find the equation of this line right here. So I always need to find M and I always need to find B. But I can't figure out what M is until I know what M is of the line that it's perpendicular to, because I don't have any information about this line except that it's perpendicular to this line. So the first thing I need to do is find the slope of this segment right here and use that to find the slope of the perpendicular bisector. So let's go ahead and do that right here. So M equals y2 minus y1 over x2 minus x1. And we know that E is 4, -3, and we know that F is 10, -7. So when I plug in this information, my y2 would be -7, my y1 is -3, so this turns into a +3. My x2 is +10, and my x1 is 4. I'm not going through how to find the slope, like I'm not teaching a lesson on finding the slope, so if you need help with the actual finding of the slope, come see me and I will help you out, okay? That's why I'm just plugging numbers in right now. So -7 plus 3 is -4, 10 minus 4 is 6, -4 over 6 is -2/3. Okay, that means that the slope, we're going to write here, the slope of EF is negative 2/3. So let me just highlight this because this is important. But I don't want to use the slope of EF. I want to find the slope of the perpendicular bisector. So the perpendicular bisector slope is the negative reciprocal of EF. So instead of negative 2/3, I change it to a positive and I flip it. Reciprocal means you flip it. So we know here the M perpendicular is going to be 3/2. Okay, but here's the thing. In order for me to be able to find the equation of this line right here, I need a point. And I don't have any points on this line, but I do know that this point right here has to be the midpoint because it is a perpendicular bisector. It cuts it in half. So the next thing that I need to do is find the midpoint of EF. And we know the midpoint formula is x1 plus x2 over 2, and then y1 plus y2 over 2. So right here, when I do this, I know that x1 is going to be 4 and x2 is 10. Divide that by 2. I know that y1 is negative 3, y2 is negative 7. Divide that by 2. So I end up getting 14/2, negative 10/2, which turns into 7, negative 5. So I know that this midpoint right here is going to be 7, negative 5. Now, all this turns into is finding the equation of a line that has a slope of 3/2, but passes through the point 7, negative 5. So this right here says to use M perpendicular and the midpoint of EF to find the y-intercept. So let's go ahead and do that right here. So y equals mx plus b. Here, I know that the m is going to be 3/2. And then I can just substitute in my midpoint, which is 7, negative 5. So put in negative 5 here for y is equal to 3/2 times x, which is 7, plus b. And this is technically 7/1. So here I end up getting negative 5 equals 21/2 plus b. So to solve for b, I have to subtract that 21/2. I would get a common denominator, which is 2. So I multiply by 2 here, multiply by 2 here. I get negative 10/2 minus 21/2 right here. So b would be negative 31/2. So now b is no longer a mystery. I know it, and then I can write my equation right here, and I can say that my final answer is y equals 3/2x minus 31/2, because I'm using these values here to find out what m and b are. Okay? All right, our last type of special line is something called an altitude. So if you notice here, this is our altitude, and it's also known as a height. And it has to be perpendicular. It has to be perpendicular to the side that it's across from, to the opposite side. And it also has to go through the vertex. Okay? So based on that, an altitude is a segment that passes through the vertex of a triangle to its opposite side at, the word the here shouldn't be here, 90 degrees. Just like we said before, since every triangle has 3 vertices, every triangle will always have 3 altitudes. It's always going to be from each different vertex. Okay, so now right here it says a perpendicular bisector. This is a typo, my friends. This should say an altitude. And an altitude does not have to go through the midpoint of this triangle of this side right here. So this is not necessarily equal to this. These are two completely different values. They could be equal to each other, but it is not a requirement that they have to be equal to each other. So I just want you to write right here that this doesn't have to be midpoints. Okay. So in number 3, it says determine the equation of the altitude from A. So here are the points that we were supposed to have for A, B, and C. Go ahead and write these down, and then we'll go ahead and graph them out. Okay, so for A is 3, 6. So I'm going to go to the right 3 and up 6. I'm not going to put any letters until I've gotten through all of these, okay? So B would be left 6, up 2, and then C would be right 4, and then down 4. And now that I've done that, I can go ahead and label my letters so I can make sure, my vertices, so I can make sure that they're not in the middle of my triangle. So go ahead, connect the dots. And what I'm trying to do is find the equation of this altitude right here. So this is what I'm trying to find right here, and it has to be perpendicular. So because this line right here, I'm trying to find the equation of this line, I need M, I need B. Because this line is perpendicular to BC, the first thing that I need to do is find the slope of BC or CB. Okay, so we'll write M of CB right here. So in order to do that, I just plug in my formula. So I'll use y2 minus y1 over x2 minus x1. I'm going to use these two coordinates right here. So y2 is -4, y1 is -2, x2 is 4, x1 is 6. So here I get -6 over 10, which reduces to -3 over 5. So I know that the slope of this segment is -3 over 5, and I know that the slope of the altitude that I'm trying to find is the negative reciprocal of -3 over 5. So here, step 2 says to find the perpendicular slope. We can say that M perpendicular is +5 over 3. So now I need to find the B. The B is unknown. So to be able to do that, I need to use this point right here because I know it's going to go through the point A. It's going to go through that vertex to find the Y-intercept. So here I know that Y equals mx plus B, and I know that M is 5 over 3. So now I'm going to substitute in the point A, 3, 6, because again, we want it to go through that vertex into this equation, y equals mx plus b. So instead of y, I'm going to replace it with a 6. Instead of x, I'm going to replace it with a 3. And now I'm just going to solve. So here I end up getting 6 equals, these 3's cancel out. I get 5 plus b, subtract the 5 from both sides, I get 1 is b. So this right here means that the equation of my line is going to be y equals 5 over 3x plus 1. Which should make sense because if you look right here, this is going up by 5, 1, 2, 3, 4, 5, and then to the right by 3. So this is the equation of the line, the altitude that I'm looking for. Okay.